going to cover proof by contrapositive, and we're going to also do an example together. Recall that an implication P implies Q is logically equivalent to its contrapositive, which is not Q implies not P. There are plenty of examples of statements which are hard to prove directly, but whose contrapositive can easily be proved directly. This is all that proof by contrapositive does. It gives a direct proof of the contrapositive of the implication. This is enough because the contrapositive is logically equivalent to the original implication. The skeleton of the proof of P implies Q by contrapositive will always look roughly like this. We're going to assume not Q, explain, and therefore not P. As before, if there are variables and quantifiers, we set them to be arbitrary elements of our domain. All right, let's do an example together. Let me erase this real quick and then pull it up. Prove that for all integers a and b, if a plus b is odd, then a is odd or b is odd. Now, the problem with trying a direct proof is that it will be hard to separate a and b from knowing something about a plus b. On the other hand, if we know something about a and b separately, then combining them might give us information about a plus b. The contrapositive of the statement we're trying to prove is that for all integers a and b, if a and b are even, then a plus b is even. Thus, our proof will have the following format. Let's let a and b be integers. Let's assume that a and b are both even. Blah, 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 blah. Therefore, a plus b is even. Here's a complete proof of this, though. So again, these two statements, same statements. One's the contrapositive of the other. But proving one thereby proves the other since they're the same statement, just written in a different way. They say the same substance. And so we're going to prove the bottom one because it's much easier to prove than the other. So let's let a and b be integers. So then assume that a and b are even. Okay, so that means then that a equals 2k and b equals 2l for some integers k and l. So a equals 2k, where k is an integer, and b equals 2l, where l is also an integer. So that means then that a plus b well, we know what a and b are. A is 2k plus b, which is 2l. Well, this is just 2 times k plus l, which is an even number since k plus l is an integer, k and l are integers, k plus l is an integer here. And we're done. We proved then that a plus b is even. And so by contrapositive, we're done. That should say contrapositive, we're done. Okay, so note that our assumption that a and b are even is really the negation of a or b is odd. And that's actually a really important point. Let me show you real quick what I did here. So you might have objected that the opposite of this statement right here, a is odd or b is odd, the opposite we said was that a A and B are even. A and B are even. And so when we negate, we're actually using De Morgan's law here. Anyways, thanks everyone, and I'll see you in the next lecture.